In today's lesson, we want to look at the interpretation of the full blood count test, also known as the complete blood count. So we are looking at the full blood count, also known as the complete blood count. The full blood count is shortened or is abbreviated as F for full, B for blood, and C for count, or CBC. So that is the shortened or the abbreviation for the full blood count, or the CBC. Now, why do we perform a full blood count test? Or what is the relevance or the significance of performing the full blood count test? The full blood count test provides an important information about the different components of blood. So blood has components. So the full blood count or the complete blood count is able to give us an important information with respect to these different components of blood. And so how does the full blood count able to give us an information about the different components of blood? The test is able to do so by measuring the different components of the cells that are found in the blood. So the full blood count, the FBC, measures the different types of blood cells. The different types of blood cells, which include the white blood cells, WBCs, RBCs, and then platelets. So the full blood count measures the different types of blood cells, and by measuring these different types of blood cells and their associated parameters, the healthcare professional is able to assess the overall health of the patient, or detect any abnormality. Overall health of the patient. So now let's quickly look at the components or the individual components that is measured in a typical full blood count test, and establish some terminologies that are applied when it comes to the interpretation of the full blood count test. So we shall begin with the blood cells and the various terminologies that are applied in the interpretation of the full blood count with respect to their low levels and their high levels. Basically, blood is composed. So when we talk about the components of blood, basically blood is composed of white blood cells, which is known as WBCs. So the first component we want to look at is the white blood cells. Now, the white blood cells, their scientific name is called leukocytes. Leukocytes. So leuko means white, and cyte means cell. So if you take the word part, leuko, it stands for white. Then cyte stands for a cell. So leukocytes typically refers to white cells. Now, the white blood cells, we describe them as leukocytes. Basically, they are divided into two types. So we want to look at the types of white blood cells, the types. So here we want to look at the types of the white blood cells. The white blood cells basically is categorized into two types on the basis of the presence or absence of granules. So we categorize the white blood cells on the basis of the presence on the basis of the presence or absence of granules. Granules. These granules are actually they contain chemical substances that the cell possesses in order to fight infections or destroy harmful foreign agents within the system. Now, there are some of the white blood cells that possess granules in their cytoplasm. Under the light microscope, we are able to see granules in some of these white blood cells, their cytoplasm. And to another group of white blood cells, we do not see granules in their cytoplasm. Now, all the white blood cells with granule in their cytoplasm, they are called granulocytes. So coming from the word granule, then we create a cell, granulocytes. Cytes means cells and granule meaning granules. So we put the vowel O to construct the medical word. So we have what is called granulocytes, meaning cells with the granules. So all the white blood cells with granules in their cytoplasm, they are described as granulocytes. Whilst those without granules, in medicine, without means A is the prefix that means without or absence. So without granules means absence of granules. So those cells without granules are called agranulocytes. So agranulocytes are typically WBCs or white blood cells without granules in their cytoplasm. So let's quickly list those white blood cells with granules in their cytoplasm. So those white blood cells with granules in their cytoplasm, they include neutrophil. So basically, this is what the scientists who discovered these cells, this was what the scientists observed. And the scientists observed that the white blood cells, we had those cells that their granules were actually attracted to the basic part of the dye. In identifying cells, we use stain, and the stain can either be a basic stain, or it can be an acidic stain, or it can be a neutral stain. A neutral stain is a stain that has both components, acidic and basic components. So that is a neutral stain. So when the scientist stained the granulocytes, he realized that some of these granulocytes, their cytoplasmic granules were attracted to, so the scientists actually used a neutral stain, and that neutral stain is called a Romanowsky stain. He used a neutral stain, we call it Romanowsky stain. Romanowsky stain, which is a neutral stain. And the scientists discovered that there are some of these granulocytes, their cytoplasmic granules, the granules in their cytoplasm. So a neutral stain has two components. It has a basic component and it has an acidic component. So the scientists discovered that there were some white blood cells that there are some granulocytes that their granules were attracted to the basic part of the dye. Now, the Greek word part for basic is abbreviated, or is in medicine is called BAS, whilst acid in medicine is indicated as acid. So BAS and acid. So granulocytes that showed attraction to the basic part of the dye, they were named after the dye they were attracted to. So granulocytes that were attracted to the base, that is the BAS. Attraction in medicine, so in medicine, if something is showing attraction in medicine is called fill. In medicine, once in a word ends with fill means attraction or love. So the cell showed attraction So attraction is called fill. It showed attraction to the basic part of the dye. We want to construct a medical word. So these are two word paths. So we drop a vowel between them. That is the general rule. In creating a medical word, we use the vowel O, which is most common. But the other vowels like A, E, I are equally used, but the most frequent vowel that is used is the vowel O. So we create the word basophil. The basophil refers to those cells that are attracted to the basic part of the dye. So one type of granulocyte is the basophil. So we want to look at the next type of granulocyte. And the next type of granulocyte, they showed attraction to the acid part of the dye. So acid and attraction is called fill. We drop the vowel O between them. We use the vowel when the word part, the latter end, the suffix actually does not begin with a vowel. So this is a consonant. So we form the word acidophil. It is interesting to note that this cell, the acid part of the dye, is actually called eosin. So the acid part of the dye of the Romanowsky stain, the acid part is actually called eosin. And for that matter, the name that acidophil is also called, it means that the cell showed an attraction to the eosin part of the dye, and that is called eosinophil. Fill for attraction, eosin meaning that attracted to the eosin type part of the dye. So that is another type of what? Cell. Then the third one, which actually showed, so the third cell actually showed an affinity for both the basic and the acid part of the dye, and hence that cell was shown to be neutral. So that is neutral. So it did not show affinity for the basic dye alone or acidic dye alone. So the cell was described as neutral, neutrophil. So these are the three main types of granulocytes. So they are basophil, we have eosinophil, and then we have neutrophil. So basically these are the granulocytes we are talking about. So all the white blood cells or any blood cell that the name ends with phil, it means that that cell is a granulocyte. Then let's quickly look at the 8 granulocytes. So the 8 granulocytes, typically the 8 granulocytes typically they are the cells that he did not see noticeable granules under light microscope. So when it was observed using a light microscope, he didn't see any granules, and those cells include lymphocytes. So we have lymphocytes. Then we have the other one, we have the monocytes. So the monocytes, these are cells that he didn't see granules. And even the lymphocytes, he divided them into 3 lymphocytes. So I'm going to talk about the common one, T lymphocytes. And then we have the B lymphocytes. So these are the common types of agranulocytes. We have another agranulocyte, natural killer cells, but we will focus on lymphocytes and monocytes because that is what the full blood count test assesses. These are the white blood cells. So when you look at these cells, so the full blood count will measure the total white blood cells. So it will sum up all these white blood cells. I mean basophil, eosinophil, neutrophil, then it will add up lymphocytes, monocytes, so 5 cells. So the full blood count will initially give you the sum of all these white blood cells, the total count, which is referred to as the total WBC count. So usually it will come as WBC. Then these different types of cells, we call them WBC differential, will also follow. Now let's look at the other cells. So the other cells in the blood that the full blood count test also measures include, so we have red blood cells. So the red blood cells is also measured by or as part of the full blood count, and red blood cells are called erythrocytes. 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 In medicine, the word part erythry. Erythry means red, and cyte means a cell. Hence, erythrocytes refer to red cells. So we have erythrocytes known as red cells. Then the other large cell in blood that the full blood count measures as part of it refers to the thrombocytes. Thrombocytes. Now, thrombo means clot, and cyte means cells. In other words, thrombocytes refers to cells that are involved in clotting, blood clotting, and typically these cells are also called platelets. So these are the cells that the full blood count test actually measured. So it counts all these cells, and in addition to these cells, it assesses the size, the shapes of all these cells, especially the red blood cells and the platelets. And so there are other associated parameters that will be measured relating to white blood cells, relating to red blood cells, relating to platelets. And so let's quickly establish. So you notice that the cells that have been indicated in the blood, so either the cell name is ending with Phil, as in this case, or the cell name is ending with cyte. So there are two classes of suffixes that describes the cells in the blood. And these two suffixes that describe the cells in the blood, these two suffixes include cells that their names end with cytes and cells that their names ends with Phil. So these are the two main suffixes. So all the cells that their suffix ends with cytes, their increase level is different from cells that their ending or the suffix end with what? Phil. Good. So now, in general, all cells, the increase level of all cells that ends with the suffix cyte, the increased level of all the cells that ends with the suffix cyte is cytosis. So when the cell name ends with cyte, the increased level is cytosis. Osis is a condition to describe increased number with respect to blood cells. So all cells that their suffix end with cyte, the increased level is what? Cytosis. So when we take lymphocytes, the suffix is cyte, the increased level of lymphocyte will be called lymphocytosis. When I take monocyte, the increased level will be called monocytosis. When I take erythrocytes, increased level of erythrocytes will be called erythrocytosis. When I take thrombocytes, the increased level is called thrombocytosis. So when the cell name ends with cyte in the blood cells, the term for the increased number ends with cytosis. This cell, reticulocyte, actually refers to an immature red cell, and typically increased number will be called reticulocytosis. Now, that is how terminologies for increased levels for all the blood cells that ends with the suffix cyte will be described. It will be described ending with the suffix cytosis. Now, even granulocytes, even though the various types of granulocyte ends with phil, but the word granulocyte in actual sense is ending with cyte. So granulocytes will be called granulocytosis. Then agranulocytes will be called agranulocytosis. So once we say granulocytosis, typically we are referring to the increased number of the granulocytes, which are neutrophil, basophil, and eosinophil. Once we say agranulocytosis, we are referring to the increased number of the agranulocytes in blood, and that is monocytes, lymphocytes. Typically, it means that agranulocytosis means that there is possibly lymphocytosis, there is monocytosis. Now, let's come to the granulocytes. So the increased number of all cells that ends with philia, the increase in number for all cells that ends with the suffix phil is philia. So is philia. So all the cells that the name ends with phil, the increased level will end with philia. So the terms, the increased level of those ending with cyte will pick the cyte. Those ending with phil, it will pick the phil. So philia means an increased number. So take for instance, if we take neutrophil, the increased number of neutrophil will be called neutrophilia. Eosinophil will be called eosinophilia. Basophil is called basophilia. So that is it. So once the cell name ends with phil, then the increased level would end with philia. So now let's look at the decreased level of all the blood cells that ends with phil. So it ends with phil. So all the decreased level of all cells that ends with the suffix cyte ends with cytopenia. So notice the same penia means decrease. So cytopenia means decrease in the cells. So is it lymphocyte that is decreased? Will that be called lymphocyte? Will be called lymphocytopenia. Then we have monocyte, decreased level will be called monocytopenia. Is it erythrocyte levels that are decreased? Erythrocytes will be called erythrocytopenia. So once the cell name ends with cyte and we want to establish the terminology for its decreased level, cyte will be described as cytopenia. So we have erythrocytopenia, monocytopenia meaning decreased number of monocytes. Lymphocytopenia means a decreased number of lymphocytes. If we have the cell leukocytes, the decreased level will be called leukocytopenia. leukocytopenia. So the increased level will have been leukocytosis. So leukocytosis means an increase in the number of what? Leukocytes. Whilst leukocytopenia means a decrease in the number of leukocytes. So then when it comes to the decreased number, so lymphocytopenia, monocytopenia, sometimes leukocytopenia can be shortened as leukopenia. So some books actually indicate shortening as leukopenia or lymphopenia. So can be shortened that way. But typically, the terms that refers to decreased levels of all cells that ends with cyte will end with the suffix cytopenia. Now let's look at those that ends with phil. So for all cells that ends with phil, all of them, their decreased level will also end with penia. Penia typically refers to decrease. So are we talking about basophil? Then the decreased level of basophil will be called basopenia. Are you referring to neutrophil? Then the decreased level of neutrophil will be described as neutropenia. Neutropenia. Are you referring to eosinophil? Then the decrease in the number of eosinophil will be called eosinopenia. So penia means a decrease. So that is the difference. When it comes to the blood cells that ends with cyte, their increased level ends with cytosis, decreased level, the same cytopenia. So penia typically is the ending suffix for both granulocytes and agranulocytes and the other cells like platelets. So if you want to talk about thrombocytes, their decreased level will be called thrombocytopenia. Thrombocytopenia. So these are the terminologies that we'll be using when it comes to the interpretation of the full blood count. So supposing that we take a patient full blood count and the WBC count is elevated, instead of saying high WBC, I will be indicating leukocytosis. So I will say that the patient has leukocytosis. Or the WBC count is low, I will be saying leukocytopenia or leukopenia. Or lymphocyte count is high, I will be indicating lymphocytosis. If it is low, that will be lymphocytopenia. So basically these are the terminologies that will be utilized when it comes to the interpretation of the full blood count. So in our subsequent lesson, we will take each of these white blood cells one by one. Thank you.